OpenCV, and I've been doing many other things. I guess I'll just start with a little update. I was running a startup, which was Array. It was basically doing like cinemagraphically accurate tracking for the film industry. So that was bought by Matterport this summer, and since then I've been working a day a week with a computer vision and medical startup, Gauss Surgical. And also, I'm trying to get the foundation into higher gear, which I'll talk about a little bit, OpenCV Foundation. And I've started a contracting consulting company, OpenCV.ai, which I'll get into later. So I'm hoping this slide is... So, just the background on OpenCV, you're probably aware of it, but it's the most popular computer vision library in the world. Now we're in an age of deep learning. We're still many times the size of and flow and developer network, actual developers' contributions, whatever, of TensorFlow and PyTorch. And I'll get into it later of the deep net things that have been added to OpenCV. But so it's this huge library around the world. It has many interfaces: JavaScript, Java, Python, C++. It's free, open and free. I developed it originally to help advance computer vision and science, because when I started, the science papers were just not anything done by students were just not repeatable. And so there were many reasons of starting the library. One, I was at Intel, and my job was to find uses of computers. Back then they were worried. The computers were running ahead of the actual cycle needs of spreadsheets and whatever. So, this was created to give everybody the infrastructure, to make code more readable, to help advance the industry, and to help, computers burn cycles out in the world. First time, and probably only time in my life, where the original plan actually worked out. That's the library. It runs on everything, all OSs and all kinds of stuff. I'll talk about where I want to direct that going further. So first, a little bit on the past, which I guess I just talked about. Having kind of lived through it, like reading the original CVPR papers, when this kind of conference fit in the room and we could all meet around, the dessert table. Now it's absolutely giant, and there's other problems with that. But back then there was no infrastructure, and it's very difficult to repeat anything people did. And so I started it to help solve the problems and the other problems of giving computers something new to do. That all worked very well. And so bringing it into presence, this was actually a little diagram at CES. It's advanced from here. Through OpenCV is now accessed through many channels. It often comes with Linux distros. It's Git is hard to track exactly what people are doing. A huge amount comes from Python. In all OS, there's a lot of Linux. There's still probably Windows still dominates because of Asia, and it's growing and booming. So we try to make estimates about how many downloads we're getting, a month or a week, and it's coming to 1 to 2 million a week. Of a lot of these are build bots, but it's extremely active, and at any given time there's 50 to 90 developers doing something. Right now we're entering the new Google Summer of Code season, so we're probably going to get 10 interns with mentors actively working on things. So there's a lot going on, and a lot of activity around this. I've now hired full-time some developers who just handle pull requests, because they began to stack up. There are companies that provide full-time developers. Intel has 4 or 5, and coming online in China, there's another 4 or 5 that's going to work around the deep net things and embedded. Of course, this was pushed back a quarter or 2 by the virus, but everybody dispersed, and they had some international team. They all went home for a while, and everybody's working at home. It slows things down, but these are coming online as resources. Right now, this full-time developer, he works all the time, and he can kind of keep the pull requests to about 50. The pull requests are what code people are contributing or fixes. So they keep coming in. It was building up. So I hired this person to deal with them immediately. And so they kind of hit an equilibrium level where at any given time there are 50 things that are being improved, and these come out in like a stately release, or you can download and build a library to get the very latest. So this is what came out recently. Well, a couple of years ago, but it's now at 4.2. The 4.0 release, it's now at 4.2. A new release is coming soon, and what happens is everything gets put into this official release. I think in the next one, the good old-fashioned SIFT operator, it was a point descriptor detector, still among the top performers. But as affine SIFT, the SIFT detector, it's just lost. The patent's expired, and so it was in a side library where we keep patented things that don't come with the library unless you explicitly download them. So it's going to be moving into the core, but just coming up on 4.2, we shifted into complete native C++ 11 compliance, getting rid of all the old and legacy code and shifting it over. The interface was kept the same. I'll go into some of this in more detail. We added this back in 4.0. So as of 2 years ago, we added deep neural network inference support. So this runs things. It's really intended towards the edge. It basically takes nets and runs them. So we're continuing to expand that. It makes it very easy in Python or whatever to run models and optimize them for the edge. It now kind of directly supports, and will expand this, Myriad X, the basic Intel chips, because Intel is supplying developers CUDA that was supplied externally. And we can make plugins which will probably expand or do this in partnership for really any kind of chip back end. And so we are talking with people like in automotive and whatever to allow that with things. It comes with hundreds and hundreds of like the latest DeepNet models. I give links to GitHub, but this is off of the OpenCV repository. So these all are things that can run. They're already sitting there. They can run just by a couple lines of code. We've made the core, OpenCV core, smaller. It's a good sign of maturity. Things are getting smaller and faster. And we've added a lot of updates of classical vision. So support for fiducial markers. I'm going to work on getting a very generic support of any kind of textured pattern, so that you get a geometric and recognition that'll probably be a fusion of techniques of deep and refinement by classical techniques, which I've found to work best. But we've done 3D support on the left at the bottom. These pictures, there's Connect Fusion or any kind of depth fusion. Fiducial markers, there's increasing calibration support with Aruco. there's dense optical flow, which I recently used in a medical product. So it's down below at right. That's color shading of someone moving. It's dense and accurate. There's things in image assessment, and so support for a lot of different verticals is there and going to increase. And now, so inside OpenCV, it's now several different modules to keep things modular and not too much that you have to download. So there's OpenCV is the core, the main algorithms and data structures. OpenCV contrib is experimental stuff. This often is closer to the state of the art. So a lot of state of the art. Sometimes we invite people to contribute. We'll be doing more of this in the future, and maybe in workshops, having people explain new algorithms, why you'd want them, and what they do. There's annotation tools, which are going to expand. So both for augmenting data and annotating it, that's CVAT. These are directories. There's a DLDT, Deep Learning Deployment Toolkit. This is contributed by Intel, but it's a general model accelerator so that you can run things in an accelerated manner on the DNN, the DeepNet library that's embedded now in OpenCV. This model zoo that I talked about, so you can find two different model zoos, one that's deployed by Intel, one by the public, but they all work on the DNN. And then there's, if you need to refine a model that you're deploying on DNN, like the deep neural network module does inference, like I said. Now, if you want to tune up those modules, you can take these models, which are O and X and whatever, but import them back into TensorFlow and train them. So there's a training toolbox, and we'll probably be expanding things in this platform as time goes on. Intel has released this OpenVINO. It's really just a combination of these tools that are focused around deploying deep nets, and so like the raw code is here, and if you download it, you get like a built version from Intel, but it's all here too. Moving on, well, I covered this. It's all C++ compliant, so modern C++ as the backbone, and then automatic and full Python coverage, and Java and JavaScript coverage. And we might expand that in a way. I don't think I put this in the slides because it's very experimental, but we have a developer working on a functional language which would allow the compilers to do the basic optimizations so that we can rapidly support this whole plethora of new chips that are coming out. So we've been emphasizing deep learning. We've done this cleanup, like I said, the core. So obsolete functionality is being moved from the core to OpenCV contrib to keep the core OpenCV clean and fast. And there's also an introduction of a graph API. It's very simple. You change the name, and then the functions that you're loaded could be optimized in a directed graph. So you don't have to worry about doing things in parallel and staging them. The graph will be used to optimize that. So that's in there and being built up. It's actually in a form that something like that is running the DeepNet optimization. So these are some now much improved things of the accelerated kernels. That's only grown since this was published. I just was taking the CES slides. Moving on. So we've added 16-bit floating point. Partly that's to support DNN that often don't need higher resolution. There's a lot in display and visualization that's been added to this. I've just shown some functionality. There's fiducial markers are better supported. I already mentioned the Connect Fusion, which is shown in the middle, and their support, which I'll get into later, for this hand-eye coordination. So basically getting the relationships between robot manipulators and cameras as part of ongoing support for robotics, but that's in there as hand-eye. Some of these things are going to need greater exposition in courseware that we're developing. I'll talk a little bit about that in the end, but and in better documentation, which we're continuously working on. I have mentioned again and again, since deep nets are big, this is really DNN. It's a deep learning module. It's really, the focus is running things on edge. So smart cameras, smart chips. There's growing support around this that we're looking at. It basically has importers for all the major libraries, but particularly anything in ONNX format, which is a standard DeepNet format. Most of the TensorFlow has indirect support for that. The others have direct support for outputting in that format of these DeepNet libraries. So this will take things trained there and run them efficiently on edge hardware. I'll get into, like, if you have code, how you might do that if you have a chip or smart camera, other resources for getting it there if you don't have the resources yourself. So it's got full interfaces. C++ is native. Python, Java, and JavaScript, so supporting a wide variety of things, and Vision running in browser directly. And below is like the back end, so there's modular backends that can support anything. There's the existing ones. We had thought to do just a general halide support, but since that's maybe not taking off or whatever, we're looking at supporting this generic functional language that we're experimenting with, and being able to then accelerate the creation of these engines. But the CUDA and Intel basically are what exists natively. It will run things on also just CPU. The most efficient in the world. So the fastest acceleration is for basic CPU. There's an ARM. One of the things that's being worked on is going to be focused on in this delayed development team is ARM support. So that's this China team where there's a lot of activity going on. They'll have a full-time development team that are paid to develop. One of their particular focuses will be on ARM support. So this is kind of for deep neural networks. It's a pipeline of how you might get things from something that's, say, an ONNX or one of the other formats. You can use the DLDT in its native format to get it into OpenCV, or you can load the model as is, and it'll run less efficiently. But once it'll be supported less efficiently in this graph framework DLDT. But once it's in there, it will then run, especially if there's a back end, it'll run super optimized. And so, like, I guess this is the first kind of plug, is like these backend interfaces were constructed nicely, but it takes some expertise to do that. So a chip maker can easily create an interface there. There's examples there about how you create an optimized interface. But one of the things, I've started this contracting company because I was getting so many incoming requests that I just said that I was, kind of giving to contractors that I know, that I just said, why don't I formalize this, that we'll get the inbounds and just handle this all in one place. So we have a team of experts. This company is just like in a week or two is becoming an official company, but we've already gotten together. We're already working on contracts that do that. There's a team. It's now approaching about 30 people who are experts in development, vision and deep net development, but also particularly expert in taking models and computer vision and optimizing and creating accelerations. Many of the companies around are actually have used these people, maybe under different names, but we're pulling it under this roof of, for instance, RISC-V implementations. A lot of them actually come from the people that are under this group now. Okay, I talked a little about the Graph API. So, here's some code that you may or may not want to see or look at. But basically, you'll just note on left and right, there's this GMAT. And this is pretty much all you have to do is, instead of declaring a math is the matrix, it's the image. Basically, you just declare them as GMAT, and you add this. You add a dressing, graph computation dressing to the algorithms. What that allows is this: it actually puts this stuff in a computational graph that allows it to optimize the computation. So you'll get oftentimes a large speed up, because in the graph you can recognize redundant calculations and sequencing. So it does this kind of optimization for you. And a lot of what we're trying to achieve, especially in Python, here it's shown in C++, is like fast, quick development that ends up being quite optimized, in the end. There's a lot of theoretical mathematical vision developers who can easily sling the code, but they're often bad at the coding part. So we're trying to bridge that gap here. Okay, I did mean the sound to turn on. Anyhow, mass to CNN. So that's just built in. Hopefully my sound didn't go away when someone killed that.
No, we can hear you.
Yeah, so now I'm trying to move it beyond. Okay, here. No. I don't necessarily want to watch this whole thing. I can move it. Okay. Yeah, so learn OpenCV.com. God, how do I get out of this? I'm trying to, I went on too far. Well, you saw, okay. Yeah, well, this is PostNet again with the sound. Okay, now I got it. Okay, so this kind of stuff comes built in. We've now, in the OpenCV.ai, stabilized the joint positions and whatever, if you want something more professional than the standard things but there's a lot of good stuff in the box. These are nets that are already in. This was my old company. We specialized in cinemagraphically accurate tracking. Those markers were just to calibrate the field. It no longer needed them. I don't know if this comes. Yeah. So this field had a few markers. We did some flyovers, and then this is with the spider cam. It's on wires. Turn this stadium in. We were, they were looking at us for the Super Bowl, not really, because they contacted us much too late for it, but we did much better tracking than the the people who did the Super Bowl. We saw all the tricks, but this is some of the stuff. Now, sort of fortunately for me, but unfortunately for the world, this company was bought, and I'm now a free agent again. I would I'm hoping to get in a year to sort of recreate this functionality, which I think has disappeared into Matterport and is going to be used for their products, but probably not back in film. And I'd love to get back to the film. So now going to try to move on. I was moved on too much. Okay, I wanted this to run. This was like something Array had done with advertisers. So that car isn't really there. It's an electric little kind of dune buggy. That's the real picture. And we got it so it could be overlaid in real time. This is all just OpenCV. And so this is all done in real time, which it was taking them 2 weeks to do it the old way. So this is the kind of thing where I would like to get back to the film industry, maybe by contract or by something like the foundation directly supporting, maybe a Disney, and like get this stuff out there again, because I'd love to bring this, there's a need for this, and production has gone way up, but it takes too long to get the quality. A lot of shows don't happen because it's simply just too expensive. I love Deadwood, but it was canceled not because it wasn't doing well, it just got too expensive to do. So this is my recent work that I'm doing, like as of this week. So on the right, just because let's start on the left. So I'm working in this medical imaging, and one of the things that the Gauss Surgical does is blood monitoring products. And so they're shipping product that monitors blood, but to do it, you need very precise calibration in clinical settings. They had this old pattern below that actually has clever reds and whatever to calibrate, but it turns out they want to get out of the business of printing these things because they have to certify them, and printers, inks, and things change. But there are these Macbeth patterns for the film industry, and so I'm just creating, and I'll probably put this on OpenCV. Like you can see the little green dots of super reliable but very lightweight detection of these patterns, and then calibrating the colors. There's this is dye, of course, but there's these bloody rags and the blood fluids that are coming off. They can accurately measure how much hemoglobin is in there. And so there's a depth camera. And so this is a shipping product that right now, when you're doing surgery, especially critical in an obstetrics, is how much blood was lost. And right now it's eyeballed. This thing gets it to the sub-ounce level, and it can be very critical depending on surgery. On the right is something new we're doing, again, internal, and with this group of contractors under direction, is this perfusion product. It measures blood flow in the skin. This is using old classic computer vision techniques and OpenCV just out of the box, but done very cleverly and clinically accurately. So this actually is measuring what you're seeing is actual blood flow in the skin capillaries. And you'll see when it comes up, when the person's going under anesthesia, the blood flow is decreasing. They're laying there with their hand out, and of course, this can be dangerous in surgery. Top of your body is getting less blood flow. You can actually be getting cell damage, whatever. That's not such a worry, but in certain surgeries, plastic surgeries, it is a clinical worry. So this is done, and this is almost wholly with OpenCV work. What we're really working on now is accelerating this, because everything they're doing is running embedded on an iPhone, and it's a trick to get it all working. So this is OpenCV going forward. There's the org, which I'm trying to pump new money and action into, and to support that, there's this contracting group, OpenCV.ai, that is experts in deep nets and optimization. One of the things we're doing my real goal is I can retire many times over. I've sold my third company. I'm now back to I want to start moving the needle, especially in robotics. Has all this promise, but there's no real deployment. The auto industry, all these kinds of players, not a single deployment. Robotics, there's all this manipulation, people doing all this great stuff, no real deployments. And in medical also, there's this huge area, medical and biotech. Vision is kind of underutilized. There are companies, but I'm trying to like put in support and maybe platforms that are supported. Mainly, like the meta goal is just to get these industries moving. Like OpenCV got computer vision moving. This is now getting back to these two areas. So many of you will probably be selling more chips if robotics actually starts happening instead of like the promise where it's not. It's all promise. So. One of the things we'll probably start doing is organizing code into more complete toolboxes, especially in calibration, which people still always do wrong in statistical methods and reliability and robustness. Again, I mentioned medical and robotics. That's my big things. And industrial factory film production, agriculture. I'm working with a bunch of people. Ag tech is big. Agriculture is amazing in the automation. It's already done. It's come at a cost of strip mining our soil. So now we need to get to techniques that aren't going to make our soil run out in 50 years. So if global warming doesn't get us, don't worry, we're going to be killed by soil depletion. So people are addressing this, and I'm working with some of them. We're doing, because I need to pump more money in this foundation, a partnership program. So getting people who can be on the board of OpenCV at high contribution, but we're setting up a store. We will come out with some smart cameras. It's supposed to be agnostic. All we're going to do is, as it goes on, is just whatever's there is quality. Like you go here and you'll get quality, and there'll be a click through to different stores and processors, cameras, sensors. These are, you can look back at this, the membership levels. I'm trying to end this on time, basically. We have a couple starting out at the 12K where they can actively address the store, and we have one potentially coming in at the kind of board setting the program. But you should see during this year the store being set up and then generalized. The first thing is to get it up and functioning, and then we hope it'll become a simplified stop for places where you're getting something that'll eventually actually be certified if people want. So there's a team that's assembling that might actually do the certification of like claims and performance. So this is getting near the last slide. I already mentioned, again, I was getting lots of inbound contracting. I get this all the time. It's how I ended up working a day a week for the medical startup. I got, no, I do not want to work, but they made it so good and fun that I'm working there a day a week, but I just can't. I was just directing most of the stuff out to people I knew. So I'm just like formalizing that and getting it together. So we have right now a handshake agreement between a lot of people that are doing the actual contracting that has shown up in smart chips and cameras, and just formalizing that. Again, a lot of the expertise is like ARM, RISC-V, FPGA optimization, but I'm in fact using them as a client to do like this medical work with this algorithm. So they're fully, people we have capable of experimentation, but also optimization. It's a very difficult thing to fit this all with all the other things that are happening. Gauss Surgical is running only on an iPhone. That is their embedded product. So iPhone 11. And it has clever optimization on that.